As Christina mentioned, I'm Brian Jordan. I'm a software engineer at code.org. I'll explain a little bit about what we do, who we are, for those of you who are not aware yet. And basically today I just want to talk about our journey starting to do Selenium automated cross-browser testing. It's been a couple years in the making, and I think it'll be hopefully helpful to those who have started testing with Selenium before and those who haven't yet, because we definitely did not know much as we as we started in on it. So I think there will be a lot to learn for people at all skill levels. So what is code.org? Code.org, we're a nonprofit that is focused on expanding participation in computer science. And so we think the best way to do that is to get computer science classes actually into schools across K through 12. The idea being if everyone has the opportunity to learn computer science during the school day, a lot of the issues with equity and access to computer science education that'll be a good avenue to address that. So one of the things that we put on each year is something called the Hour of Code, and I think this was actually kind of one of the first events that code.org ran early on, right before I joined. In 2013 was the first one. So I have a little video here that explains a little bit about what the Hour of Code is, and I'm going to play it. I'm going to try to take out my headphones and turn up my volume so that you can hear the video. Otherwise, Christina will post the link to the YouTube video if you want to watch it on your own later if the audio doesn't end up working out. Cool. Pull this out. All right.
Okay, now you're going to press run. This is so cool. Hour of Code todo. Ya programé a Codeman y luego Hackcode.
Your teacher says you guys are into it.
We are. It's very awesome.
Code.org has partnered with 30 public school districts across the country, including New York, Chicago, and Denver, to provide lessons in teacher training and writing.
The largest education events in history.
Organizers set what they called an ambitious goal, reaching 10 million students this week. Almost 15 million signed up.
This week, I'm proud to join the students, teachers, businesses, and nonprofit organizations taking new steps to support computer science in America's schools.
I ran an Hour of Code. It was easy to do.
I got it. They've been so excited about it.
They don't even have to be a computer science engineer. Maybe they want to do something else. But in our world, this is going to be the basis for everything that we do.
When you're building a program, you have to think outside of the box.
If you can change technology, you can change the world.
I challenge girls in every single country to learn 1 hour of code.
Every district should do, every district can do it. Please help us get the Hour of Code to every school and every classroom and every child.
And my school's doing it.
All right. Hopefully some of you were able to hear that. So what is the Hour of Code? If the video didn't quite get that across, the Hour of Code is this yearly event we run, which basically challenges students across the country and their teachers to just try out 1 hour of code during Computer Science Education Week in December. So typically each year we'll put together a tutorial, some sort of an interactive computer science programming tutorial, very simple drag and drop. You do stuff like move forward, turn left, and you learn a little bit about loops, maybe conditional statements, just to give a little taste of computer science. So the results from that, over 200 million students and teachers have tried the Hour of Code. But just trying 1 hour of code is not computer science education in K through 12. So what are we doing to actually get computer science into schools K through 12. So beyond the hour of code, what code.org works on, and I think is actually the bulk of our work and what I work on, we're putting together full computer science curricula for K through 12, so that teachers who want to teach computer science have something that they can build off of and learn to teach and then teach to students. We're working on district partnerships to get large cities who are interested in running teacher trainings across their district to be able to run those and start to get it to count as a credit. And then on the policy change side, we're actually working to lobby to get states and the government to start counting computer science as a real credit alongside other subjects. So the part that I'm going to be focusing on in this talk and what I spend most of my time working on at code.org is our interactive K through 12 computer science curriculum. So our computer science curriculum is an online interactive learn to code curriculum, and it depends on kind of whether you're in elementary, middle, or high school. It ties into our teacher training. So we've had around 20,000 K through 12 teachers trained so far. And a lot of students and teachers have tried our intro courses. So what do they actually look like? And I think I'll actually show you a quick demo of what our website looks like so that we know what we're actually going to be testing and working on testing in this session. This is our main interface. I'm actually going to pop out here into one of our activities. So this is kind of what our interface looks like. This is our Flappy Bird levels. That was for it's kind of a fun little mini course. You can see on the left here you have a bunch of blocks. Each one of these blocks is something that you can drag and drop into this little coding area. So you can kind of imagine this as like a little basic IDE where you can write some code that then when you click run on the left here, on the left side of the screen here, will make the game do something. So what I'm going to do is I'm going to say when run, I'm going to set the speed to normal, and when I click, let's make the Flappy Bird flap a normal amount, and then we'll play a wing sound. So then when I click there, the speed starts going, and when I flap, Flappy Bird flaps. That's kind of the basic idea with our tutorials. It's kind of simple drag and drop coding, and then when you're done with your code, you can share your code and see the JavaScript underlying your code. So one question that I think I get a lot from friends, and I think some people in the webinar posed a question similar to this, just kind of like, how do you even get started automated testing, and why do you start automated testing? So in 2013, after our first hour of code, we didn't have any sort of Selenium UI automated testing at all. We had our tutorial, we had the first pieces of our 20-hour curriculum, but there was pretty minimal testing just because early on it was a matter of just getting it all done fast enough for the event and just getting it out the door. So why would we want to test? Why would we want to invest in putting together automated tests and cross-browser tests? And what's kind of special about our context for this? So obviously in our context, it's getting used by kids. It's getting used by teachers who are supervising kids using our curriculum. So it's very important that we have a good level of solidity on our website, because this is in a context where if there's a bug that's blocking a level from being completed, it could actually block an entire classroom of kids from doing what they sat down for that hour to do. So it's really important that we have stability, but at the same time, we want to be able to develop quickly and push out new features and fixes and curricula without a very long QA process. So what else is special about our context that maybe makes it a little more challenging than normal to run these automated tests and get full coverage of our context? We support a lot of different stuff. So we have, if you imagine, for those of you who had any sort of computer classes in schools recently, you might remember the types of computers that you'll find in school and the types of restrictions on those computers and firewalls and browsers and, lack of options of installing things. So basically, what we try to do is support as much as we can. So our curricula work on iPads, Chromebooks, IE9. We work on Firefox, Safari. Basically, everything that we can get it to work on, we try to get it to work on. So obviously, that ends up creating a lot of edge cases that we do want to test as we make changes, as we have found things that break for these specific browsers. The other thing is we're extremely localized. We have internationalized. We have over 40 languages now supported. Here's our giant drop-down when you click the language drop-down. We also include a few right-to-left languages, which actually ends up flipping a lot of the content on our website to be aligned, right-aligned, and it's pretty amazing actually that the entire site kind of flips. So a lot of the layouts change. A lot of there's conditional logic in some of the JavaScript that does programmatic layout. So it just kind of increases the surface area for potential bugs. Oh, speaking of increasing the surface area for potential bugs, we use a lot of leading-edge web technologies like SVG and Canvas, and doing funky things with them, like dragging and dropping them, and animating them, and hiding and showing them, and laying out based on the sizes of them, which you'd be surprised ends up being something that can bite you in many a browser. So how the heck are we going to test all that, right? I think what we ended up finding was we were finding bugs in these weird edge cases, a surprising amount. You'd think, oh, okay, if you use jQuery or something, you'll be fine. But turns out there are a number of things that, a number of cross-browser bugs that are very edge casey and involve complex interactions between components that even the most awesome cross-browser JavaScript libraries don't make obsolete. So how do we actually get started Selenium testing? So after 2013, when we were starting to work on our longer 20-hour curricula for kindergarten through 5th grade, Hadi Partovi, the founder of code.org, he's like a well-known investor, entrepreneur. He's a former engineer. So he was in contact with a lot of different companies who had been saying, you got to try out this continuous integration, continuous deployment, continuous testing. It's made a huge impact. So he kind of saw it, the benefits of it at other companies. So he basically asked one of our engineers to do an investigation into what would it take to get cross-browser tests, because we had also been finding these cross-browser bugs. And he figured now's a good time to invest in trying to get a little something set up. So Brendan, one of our very early engineers, still around, he ended up setting up a cross-browser testing script that used selenium-webdriver and Cucumber for the DSL for the steps. Very basic to start. I'm going to show you real quick what some of those kind of look like in practice. So all of our code is open source, which is kind of the nice thing about this, is that you can actually see what we actually do with tests because it's all on GitHub. As a nonprofit, we try to be transparent and share back what we do with the community. So all of our stuff is in this folder. I think I can send out a link to it a little later too. At the end of my presentation, I'll have a link to it. This is our dashboard test UI folder, and it's evolved over the years, but the main little bit of magic right here is the runner.rb file. So runner.rb is our test runner that is actually a command line client, has a bunch of configuration options, and it actually takes in our giant list of browsers, does a bunch of setup, and I'll get into some of the more details of exactly what it's doing, but it's actually ends up running these Cucumber features in parallel. So what does a Cucumber feature look like? Here's an example Cucumber feature of ours as I mangle it with my keyboard. So Cucumber is for those of you who are not aware, it's a domain-specific language-based kind of test writing tool. So you kind of write your tests somewhat in what looks like English. So you can define your feature. So we have a bunch of, our tests are organized like this. We have a bunch of feature files in this folder over here in our dashboard test UI features folder. There's quite a few features. And each feature has a number, each feature file has a number of scenarios. These are kind of titled scenarios. Says, go to this web page, rotate to landscape if you're on a iPad or something like that. And then I wait to see a dialog titled puzzle 1 of 10, and I close the dialog, that sort of thing. And so each one of these steps, underlying it, you can see actually in RubyMine, the editor I'm using, it kind of highlights it. It understands a little bit about what these steps are doing. If I actually drill down into this step using Apple down in RubyMine, it jumps over to the steps.rb file. So it jumps down from the step definition, from the step usage to the step definition. And you can actually see underlying what's going on here. This one happens to actually be a combination of a couple steps. So other steps will say, and so actually the way that these are structured is the Cucumber DSL, you define these steps that are regular expressions that check, that basically have the definition of the step, and you can pull out information from the step definition. So in this case, a lot of the usages are saying, and I see a dialog titled, and then a little name of what the dialog should be titled, and then it uses that text in the step definition, in the actual step running. So some of our steps that we've built up are things like element has text. So this is in our little browser helpers file. This ends up executing a script on our selenium-webdriver browser object, which ends up getting defined in that first step there, and then runs that JavaScript on the browser, takes its result, and asserts something about that after the end of that step. So that's kind of just a very high-level overview of what this kind of looks like. So we have our runner file. Our runner file loads in our list of browsers. It will run all of those currently in parallel. I'll get into a little bit about the evolution of how we got started running parallel tests there. Runs it using the Cucumber command, which ends up in our connect.rb. We end up actually connecting to Sauce Labs here. So we set the URL, we give it our Sauce Labs authentication information. We set a couple of browser capabilities, and we pull in we have our browser information from the JSON file that we've grabbed there. And then we actually initialize a Selenium WebDriver for that remote URL in Sauce Labs. So that was kind of a whirlwind tour. We'll dig into some of the details of what that all meant, but I wanted to give you a very high-level overview of how this is all structured for us. So we have our features folder. We have our step definitions files, which have those Cucumber steps defined, the nitty-gritty details of what those high-level English things mean. And then we also have our little connector helper file that connects to Sauce Labs or conditionally to other browsers as well. We'll jump into a little more of that. Don't want to overwhelm you at this stage, but I just wanted to give a high-level overview of what that actually looks like in practice. And so a lot of that was stuff that when Brendan went in early on to kind of frame it out, I think he set up the runner.rb file. He set up a test feature file, and one of those original steps.rb files. And over time, we've built those out across the entire team, adding new features, adding new functionality to those. So what are some takeaways after having gone through this process of setting up these tests? And at this point, I think we've actually been working with them for maybe about a year and a half. And bearing in mind that I think none of us had actually had much experience working with Selenium tests before. So it's something we were all kind of learning along the way. So we've learned some best practices over time from other people, and we were like, oh crap, we probably should have done things differently or used page objects or other stuff. So our stuff is probably it's kind of a naturally evolved sort of testing situation. Some of the stuff that we've learned though, one of the valuable things I think we got a lot of mileage out of throughout the time that we've been testing is the value of building up a library of steps. So when you're adding a new feature and you're adding a new test and you find, we don't have code that can actually drag a block from here to here yet. It's often worth investing the time in writing that step and testing it out and making sure it works, because it's going to pay off down the road when we're writing new levels and new functionality. We'll be able to actually reuse that step and have an example feature that we can build off of, which I've found has been very helpful. The other thing that we found useful was actually building up a library of test levels. So instead of actually loading up a level that's live on the site, meaning a level that's within one of our curricula or one of our hour of code levels, we found it's actually better to create these kind of standalone test-only levels that are still exposed to the world. They're still publicly available on our website and all of our environments, our staging, test, and production environments. But the nice thing is they're separate. So as our level builders, we have our education team actually works directly on our levels within an editing environment. So they can make changes to the production levels, but they won't end up accidentally breaking one of our tests, which may be depending on some sort of content of one of these levels. So that was a lesson I think we learned. We learned probably later than we should have, that don't mix your test data and your production data if possible. It's tempting because you're saying, oh, here's our actual curriculum, and we want to test out our actual curriculum. Why don't we just point the tester at the curriculum? But what we found is that, those end up being slightly more brittle tests. So it's nice to have those separate, but still try to cover the same amount of functionality. The other thing that's kind of cool is annotation. I don't think I pointed out any annotations in the test earlier, but annotations are, at least for Cucumber, and I think they're a handy tool. You can actually annotate your test. Let me try to find one that has some interesting annotations. So here's a simple annotation. So at the top of this scenario here, this is a test for one of our function editor dealies. It has the scenario definition, all the different steps. At the top here, we include an annotation of Chrome. So that basically means run this test only on Chrome. So oftentimes I think we'll do that for tests that we don't really care about the cross-browser characteristics of, or it's using some sort of WebDriver functionality that we only know to work in Chrome consistently, that sort of thing. So we have a number of other ones. So we have no mobile, which is, I guess, maybe self-explanatory. Don't run this test scenario on mobile devices. No IE9. So if there's a known failure in IE9, or sometimes the IE9 WebDriver is not completely always consistent, so we'll mark a test as no IE9. Skip. It's the lazy man's way of commenting out a test. If something's super flaky, you can just add a skip and maybe get back to it later. Or just delete the test because, it's still in source control. The two kind of cool ones that we added at some point, one of our engineers, Laurel, she ended up adding the ability for us to interact with the Rails database through a lot of the Rails helpers while within the context of the tests, meaning you can write a UI test that says, log me in as a student. And instead of actually going to the web page and creating a new account that's now going to be on our test environment or production environment, it'll actually just have the test code itself, the Ruby code of the test code itself, create a new student in the Rails database and log you in from there. So that sort of thing, we actually mark those with DB access, because let's say you're running a test from your local machine against production machine, you won't actually know, you won't actually be able to access the database necessarily from that context of your runner. So it's kind of context dependent, but we found that to be a very helpful annotation, because you can then just quickly log in. And I'd be curious to actually hear how other people handle logins on sites. I think some people will actually have the driver create an account or something similar to what we do. So okay, that's all cool. We have this test framework. We have all these tests, from when someone set up the framework. But come on, who is actually writing the tests when it comes, who's actually writing all those .feature files over there? So at code.org, we actually all write tests. We don't have any dedicated test engineers. We kind of all take on a little bit of the responsibility on our own in terms of both testing our own features. So it really is up to the engineer working on a given feature, whether they want to write a cross-browser test, whether they want to write a unit test or some other more low-level test for their feature. So we actually all end up writing these UI tests, and so it's kind of one of those test your own thing. Otherwise, you might be hearing about the cross-browser bug for it later down the road. So we all write tests, which is great because we end up building up a library of different useful step definitions, a lot of example code, and we have a lot of just general team knowledge on how to respond to test failures and how to investigate them, and and just it generally, I think, it increases the coverage that we have. So who or what actually runs these tests? Well, obviously, if you're the one writing the tests, you're going to be the one who runs the test to confirm that your test actually works, right? But who wants to find out that your given test has since broken? Months down the road, someone says, "Hey, wait, this test is broken." What? It's been broken for 2 months. That's no good. So we actually end up running our tests in our continuous integration cycle. So actually, currently, our continuous integration is run on. It's basically a series of scripts right now, and I think we're hoping to move it off onto a service pretty soon. Right now, it's kind of a series of scripts on provisioned servers. We have a test server, kind of a very beefy EC2 server that runs our tests with lots of parallelization and for various reasons requires a lot of memory on that machine. So we run the tests in our continuous integration test environment. So that ends up looking like we create a pull request from our staging to our test environment, and when the test environment gets the GitHub the git commit hook coming in, it will actually kick off our tests, start running our tests. It does our full site build, builds all the components of the site, starts a local running instance of the site, and then it runs our runner against the site. So I guess the answer to that is right now, both engineers will run the tests on their own when they're writing tests, and then our continuous integration environment will continue running the tests periodically to make sure we have not broken anything. So what challenges did we end up facing while we were writing tests? What sorts of things ended up being tougher than maybe one would expect? Well, of course, the big challenge for us, as I alluded to in the introduction, was we support a lot of browsers. So how are we going to test all those browsers, right? That's kind of the whole point of the exercise. And what does that actually look like? So we use when we use selenium-webdriver, it's a Ruby library that will run the selenium-webdriver against a given URL. And then we use Sauce Labs to point our selenium-webdriver at the Sauce Labs, our little authenticated URL there. And then we can actually run against different browsers. I guess that's also encoded in the URL that we pointed at. So we say, basically, give us an IE9 Windows 7 browser, and it connects, and then we start running our tests against that. So what does that actually look like? So what is where's the actual list of browsers live, and what does it look like? So this is our browsers.json file. It's basically a list of objects. Each one of these little things is a little data object that represents what browser we should be running that thing against. And these correspond to identifiers that Sauce Labs understands. There's a list on the site, and I think we're running against something like 10 or 12 browsers, and those are in this list, and then we parse that list when we're running the runner. As you can see here, we load in, this is in our runner file, we load in the browsers.json file. We load up all of our feature files, We then choose which features we want to run, depending on whether someone passed them in from the command line or something like that. And then actually we do a product of we kind of multiply out the browsers by all the features. So each feature browser pair is something that we're going to run, and then we end up at the bottom here running those in parallel, using the Ruby parallel library to run multiple instances of the Cucumber runner in parallel to speed up our test, which I'll cover a little later as well. So what does this look like when this is actually running? If you log onto the Sauce Labs website, you can see your actual individual tests running. So actually, let me pull out my presentation real quick, and I'll show you kind of what that sort of deal looks like. So here's kind of a test page that I've loaded up. So here's the main kind of giant list of tests. Here's all the tests that we've been running. You can see these are a bunch of Windows 7, Chrome 48 tests. And then if I drill into one of these tests, let's say one failed and I was looking at it to see what went wrong, you can either watch a playback of the actual test itself, and that'll kind of show what went on in the test. So this test is resetting, going in, looks like it's maybe gonna create an account and log in, and then it's going to, it already created an account, it's logging in, loading up the page, going to the game, to the puzzle, and then I guess it goes through a couple of levels just to make sure that it loads up. I think maybe it's checking progress or something like that. Signed in progress, and it's done. Then sometimes if you need to debug a test, you go into the command section here, and you can kind of watch what happened frame by frame. Keyboard shortcuts to scroll down, see what happened, make sure everything went all right. If something went really wrong, the log section's handy. You can check out the Selenium logs. Sometimes there's checking out both of these is worth it. Just different styles of logs. Usually you can match these up to the actual steps themselves. If you really need to dig into what was the JavaScript that was running here, you can see like, oh, here's the sign in button dot click JavaScript, and what did that return. Sometimes when you're debugging a faulty test, you want to look into it at that level. So that's cross-browser testing. But what about when you don't necessarily want to actually run your tests against Sauce Labs? Or, for example, what if we have an external contributor, like we did last week? You know, as an open source project, we often have contributors come on who don't have our Sauce Labs authentication credentials, but they still want to write a UI test for us, maybe and just run it against, you know, their local browser. So there's kind of two ways of running local tests that you're working on. I guess the other context is, let's say I'm writing a test for a new feature that I just wrote on my local machine, and I want to run my test against my local machine. So those two cases, on the one hand, this first solution here, chromedriver, that's the option for if you are writing a test and you don't have, and you don't want to run it against Sauce Labs in the cloud, or if you don't have credentials for Sauce Labs or are credentials for Sauce Labs, and you just want to run the test against your local machine. So you can use chromedriver, which is a headless instance of Chrome, and that'll kind of pop up on your screen and let you watch your tests happen in real time. And actually, you can even pause the test and interact with the console or the debugger if you actually need to debug your test, and you know, you have some front-end code, you want to check if there's some sort of error. That's pretty handy. So then if I actually wanted to run the test against my local machine, we can use Sauce Connect. So that's a handy SSH tunneling tool that lets you actually connect your, have Sauce Labs browsers run against your local machine. So if I have some local changes that I want to test, you know, in IE9, then I'll start running Sauce Connect and have that run against, and so then I'll actually point that to my local machine using that URL. Other tools like ngrok, or basically anything that makes it so that the remote machine can access your local host. What are other challenges? Man, so many challenges, right? Here's another challenge. We have a lot of interaction on our website, right? Drag and drop coding. This isn't just typing something in. This isn't click a link, click a button, go to the next page. go to this URL, click the thing, check the text. We're actually dragging and dropping stuff, and there's some serious logic underlying that we want to make sure that we cover. So how do we test that interaction and drag and drop? There actually, I think there are some Selenium helpers for that, some native ones, but we found that those for some reason or whatever don't work across all of our required browsers. So something we found actually very helpful for, especially for the Blockly drag and drop coding interface, is jQuery Simulate. So it's a jQuery plugin that lets you just take a selector and then it simulates a drag, kind of step by step a drag interaction. And we found that it's actually a pretty good surrogate for native dragging, and that actually ended up working out very well. And actually, we'll see that running in a little bit in the little. I'll show you guys a quick little test run of what it looks like to run these tests. How do you handle intermittent failures? So what happens when your tests actually break? So you're running our tests on our continuous integration system, and it starts flashing red, right? This test is broken. So that's, on the one hand, maybe something actually broke, right? So you want someone to investigate that and figure out what it was that actually broke based on that test. But what if the next time you run that, it works again? So I didn't think that was the thing, but apparently this is a fairly common thing that will happen with Selenium tests. Because they're complex, oftentimes they're dependent on timing. They're actual browser clients, so sometimes the page will take longer to load, an action will take longer to complete, or maybe there's something going on with this specific WebDriver for that platform. There's a lot of complexity in each one of those WebDrivers for that browser. So intermittent failures actually happen. So of course the solution is to always fix your tests, except when rerunning works. So sometimes you actually just want to rerun your tests. I've spoken with other people who run a lot of tests, and they all end up rerunning. It's in a perfect world, you'd think, right? You just never rerun your tests because you should just fix it instead. But it turns out there's kind of, it seems, as far as I can tell, there's a class of issues that you just can't make your tests always work perfect. It's kind of a trade-off of do you want to spend the time really digging into each little nitty-gritty cause of each test failure? Oftentimes it's very, very low-level, timing dependent, hard to reproduce. So testing it out takes maybe 20 minutes. Or it takes a couple minutes to get some feedback, and then you have to test it a bunch of times. And then it only reproduces some of the times. It can be very time-consuming. So oftentimes, if it's just a slightly and not very often intermittent failure, I think it's probably okay to rerun. And I've heard that a lot of other people do that, and that it's an okay thing to do, recommended thing to do. For the ones that we were able to investigate, what actually causes intermittent failures? I think I'm certainly no expert on intermittent failures, and there's so many different causes. I'd say usually what we end up finding is that it's some sort of a timing issue. So if it's working once and it's not working the next time, usually it's something to do with the page isn't completely loaded, or this piece of JavaScript hasn't run yet that sets the page up in such a way that this next step can be completed. So oftentimes what ends up being is trial and error, adding waits, explicit waits to say, wait until this element shows up, and then perform the action. So oftentimes that'll end up being the fix when we say, okay, we found the fix for an intermittent failure. Other times, the intermittent failures seem to be somewhere at the actual WebDriver level. There'll be a crash of a certain browser's WebDriver. Oftentimes those are in browsers like the IE9 ones. Sometimes iPad. I think maybe that's kind of just the latency based or something like that. But yeah, it's kind of always a constant struggle, and it's always a trade-off of, should you just rerun it? Your test will take a little longer to run, or should you actually take the time to investigate that specific one? It's kind of a bit of a time trade-off. So one of our engineers, Laurel, she recently went out and actually found a way to measure the test flakiness of our tests using the Sauce Labs API, which is super cool. So this is in our repository. She did this, I think, just last week, which is awesome. And she created kind of a magic retry mode that uses the flakiness data to determine how many times to rerun a test. So I would certainly recommend checking this out if you are curious to see the flakiness of your own tests. If you happen to be running cross-browser tests already, you can pop this thing open. It's in our repository under libcdo test flakiness, and it pulls the Sauce Labs API, collects the samples, and basically gives us a little output of the flakiness of tests. So actually, when we run our tests, in our continuous integration output and in HipChat, you get a little list of the flakiest tests. So we know what to look at, the kind of highest impact tests if we want to speed up our runs, or maybe stop running those if they're not worth it. So what do tests actually look like when running? So I'm going to play a little bit of the speed run. I see we're actually kind of getting a little low on time, so I'm just going to show you a little bit of what it looks like. This is running, I think, most of our test suite against my local machine on chromedriver. So here you see a bunch of crazy stuff happening. You got the Star Wars Hour of Code being played by a computer, which I think is awesome. The computer is learning to code, and it's doing very well. Moving BB8 all around. So those are those ones. Let's skip forward a little bit, see what else we got. So here's some other drag and drop ones. Here's our this is our Minecraft Hour of Code. Here's our Anna and Elsa. Yes, the Minecraft one. Generating a certificate. By the way, this is sped up, so our tests don't actually run this fast. I would love it if somehow I could speed everything up like this. I mean, actually, I'll get to that in the next section of how we actually do speed things up. But yeah. So, not wasting time, right? Sometimes people will come to you, or you're having a team meeting, and someone will say, "Is it really worth writing all these tests? Like, come on, we're spending all this time writing these features. When something breaks and it's not a real breakage, like we're losing all this time because we have these flaky tests. Are we really catching any bugs?" So, a couple of things. First, I'll cover kind of how to make things a little less painful on that end, and then I'll also cover kind of how to think about that investment that you're making. How do you speed up test runs? Here's a little funny XKCD comic. You can check it out. Maybe I'll post a link to that too, about how much time you could save how much time you'd save if you were to shave off a certain amount of time from a repetitive action. So I think this is it's kind of a graph of, if you want to look up, let's say you run your tests 5 times a day. If you can shave off 5 seconds, then you would save 2 hours over a year. If you could shave off an hour, then you'd shave off 2 months. That sort of thing. Nice way of thinking about that. So in 2014, our tests had gotten really long. They were probably an hour to 2 hours of tests. I think we were running a little bit of parallel, like 5 to 10 instances. What we started doing is parallelizing much more and across every feature, not just every browser. So as we saw before, there was the browser features product. This is work that Laurel did as well. She basically got our test machine running on a much beefier EC2 instance, much more memory. We're able to get up, I think right now we run consistently at around 70 parallel instances. Our tests are way down, so if this is using the Ruby parallel library, and Sauce Labs, you can configure it to have more concurrent VMs. So we were able to run these in parallel now. Oftentimes they'll end up, somewhere between 20, 40 minutes, way down from before, and actually we have way more tests than when we started this. And so that's, I think actually in the bottleneck right now is not the browsers, it's our machine itself. So hitting the machine with 70 concurrent users, all kind of also running Rails instances to create logins and that I think actually ends up being the server machine that we're running the tests on being the bottleneck. So we're hoping to make that even less of a bottleneck in the future. So how do you justify the test? You're having that team discussion and people are saying, why do we even test stuff? Like, do these actually break anything? Like, why would we even invest all this time? We're all writing these tests, we're installing the Ruby gems to run the runner, and we're investigating broken tests. How do you justify it? So one thing that we started doing is collecting bugs, because every time we'd have one of these conversations, I'd be thinking, I swear there's like 5 to 10 bugs like in like Firefox alone that we caught. Like we gotta keep these cross-browser tests. It's so tempting to get rid of them, because you could say, well, then we could just run them against one, or just run them on Phantom.js, and we will that. But at least for our purposes, we have caught quite a few cross-browser bugs, and so we started a bug collection on our wiki where when you find a bug, you add it to this wiki page with a little description, maybe a screenshot of what went wrong, so we know which types of investments that we're making are paying off, and maybe which ones aren't. Like maybe we're not finding bugs using a certain type of test. So here's one where we actually started using. I think I might have moved this a little later. So we actually started using Apple Tools, which is it's a tool that lets you take screenshots during your test. So we run it against Sauce Labs, and then we say, okay, at this point, take a screenshot. And then Apple Tools stores these screenshots and compares them at the end of our test runs. So this ended up finding this button being removed from an unintentional button removal in one of our work in progress curricula. Here's a couple buttons that got duplicated accidentally in one of our curricula. These all got caught before we actually ended up deploying. Here was a huge one. Firefox get bbox for SVG rendering does not measure properly, or I think it throws an error when you try to measure it on an invisible element, so it caused this thing to get all messed up. So good thing that test was in place before that got deployed. Here's one of my favorite bugs. What's the difference between these two slides? I'm going between the two, right? Maybe it's obvious when I'm doing it really quickly, but it turns out the line height between these two actually ended up changing. So there was this a refactoring that occurred in our CSS, and one of the line height settings there got changed or removed, and it fell back to a different height. So our page got longer, which I think we probably never would have noticed if we hadn't had a test in place that was taking that screenshot and comparing it. So who actually ends up investigating these failures, right? We're all writing tests, but come on, don't we have someone hired to follow up on the broken tests and make sure they're running and write new ones? No, we actually all do. The way we do it is each day we designate a dev of the day, basically a person who we, instead of whenever anything comes up, we say, we're all like, oh, looking into it, like 10 to 12 of us all looking into the same issue. We say, we designate a dev of the day and say, if anything random comes up, if any test failure comes up, any issues in the deploy, live site issues that need immediate attention, the person who's designated for that day does it. And we found that that really helps reduce a lot of the randomization that'll happen just naturally for across the team, because it's then relegated to just once every week or two. And it's nice because we all kind of get to know what goes wrong on our site and what goes wrong with our continuous integration tests. So we're all kind of building up a bit of knowledge about how our test runs work and what sort of intermittent failures might come up and how to respond to them. So what's next for us? The thing I think I'm most excited about right now is setting up per pull request tests. So when someone creates a pull request on our site, it will automatically run our cross-browser tests against Sauce Labs from our continuous integration service. And I'm kind of experimenting with it at a couple different services right now. Almost got that working. Pretty exciting. What are some takeaways from this? Start small. If you haven't started getting tests set up yet, I think it can seem daunting. It's like, what? They have like 100 tests And like all these support files, how do I even create a test site? Start super small, you know, just like set up a Ruby file with selenium-webdriver and just test that the connection works and make a couple of commands, or try to go find a good boilerplate sort of thing to start with and clone that repository and try it out. And over time, you'll build up more tests and just test your new features as they come along. And I'd also say something that has worked out great for us is just having everyone write their own tests. We've just built up a great library of testing components, and everyone's learned how to test, and it's been amazing just across the team. Everyone's been contributing little fixes and speed ups, and it's just been awesome how the teams kind of come together to make these tests run quickly and have a lot of great coverage. I think our bug rate's much lower for it. And yes, periodically invest in speed ups. Yeah, like at one point, Laurel took the time to add a bunch of parallelization to our tests and to get the flakiness monitoring in and automatic rerunning going. And I added the Apple Tools test at one point to start getting the screenshot-based differences, which ended up kind of making our tests cover a lot more with a lot less effort. So yeah, that's pretty much it. The two things I want to shout out, if you're interested in Code.org's mission and generally interested in helping, we often have opportunities for volunteers to help out in classrooms. So especially if you know a bit of coding or are passionate about teaching computer science, even if you don't know too much coding, you can check out our tutorials first and then go help out. Code.org/help. We'll let you know when volunteer opportunities come up and advocacy opportunities to write legislators across the country, that sort of thing. And then our GitHub repository is github.com/code-.org. And I'll send a link, I'll add a link in the chat to the actual GitHub repository with the folder with our tests in it. And you can check out our tests themselves. And if you're super interested in our tests in particular and you really want to help make them better, you have some cool idea for something that'll make them run better, or some new tests or something, you just want to play around with it, feel free, reach out. That GitHub repository, we have a way of getting involved with our contributors program. So if you want to contribute something to our code base, we'd be more than happy to have you on helping playing around with these fun tests. So yeah, that's it. Any questions?
Yes, we have had some questions coming through as you were talking. So let's see here. First question, how much full-time, FTE, full-time equivalent do you spend on the automated testing?
Oh, I see. How many, maybe FTE full-time, how many full-time engineers do we have focused on automated testing? Yeah, so that may have been asked prior to the section about just our testing culture. Yeah, so we actually don't have anyone dedicated to testing at all, really. It's kind of been a write your own tests, enhance the framework in ways that you feel are helpful to the team. We're a pretty small team, actually, as I should mention. I think we're something like 10 to 12 employees right now. So we're not too big. So we all kind of take a little bit of responsibility for the tests. I could imagine actually as the team gets larger, you might want someone or even maybe even a team at a certain stage that is focused on keeping the tests running quickly and improving the framework and following up on test failures. But yeah, I think it's over time it almost seems like it's getting to the point where everyone can kind of individually manage their own tests, as you have services like Sauce Labs and the continuous integration like Circle CI that can run your tests against every pull request. I feel like it becomes less of a maintenance issue when everyone knows when their own code broke something. So hopefully we're moving to a point where it's kind of get your test set up, and they stop you from breaking stuff, and they tell you as soon as possible who broke what, when, and they can fix it.
Right. Yeah. There's just a common theme of questions that are asking kind of the same thing, where it's just like at the end of the day, like how much of the time is it really taking, since you don't have those dedicated people, and specific questions around that as well was, you know, if you have a constant UI changes and that can break some of the test scripts, you know, the test team needs to test the functionality and automate simultaneously and make changes to the test. I think people are wondering kind of how much time does it really take to really manage all of those issues?
To maintain and manage. That's a great question, and it's definitely something that has changed over time, and I think depends on the type of test. So yeah, I'd say two things I'd like to kind of show. So on the one hand, for visual tests, right, visual changes will come out and break stuff. Well, yes, actually with both of those, I'd say ideally those tests that break. So I think ideally that those tests that would break, we'd catch those in the pull request branch of the actual break itself. So I think that's where we're moving towards. And but you know, at the same time, I'm speaking speculatively about that. So currently and kind of in the past, I think the worst that it had gotten would be like we're not, you know, when we were running our tests and they weren't running as often, when our test run took an hour to 2 hours, it's almost a function of how long our tests take is how much time we have to spend following up on breakages and trying to figure out what caused those. So when our tests are a lot shorter, we run our UI tests more often, so it's more obvious what broke what. So if it's down to like 1 or 2 commits, we could say, hey, like this test broke that's clearly related to Flappy Bird, and you had this commit that was Flappy Bird related from minutes ago. You know, could you check this out and fix that? But ideally we could get to the point where you can't even push that thing until the UI tests all passed before even merging your code in, so that it doesn't get mixed up and we know what broke what. In terms of time spend, I think at our worst time was probably maybe a year and a half ago. We were just having a lot more intermittent failures. I think it was connectivity issues, just random stuff. And we didn't have great rerunning set up. We didn't have very simple rerunning steps written. It could often take the dev of the day. Maybe they'd spend on a bad day like an hour just debugging the tests and rerunning them and making sure they're just making sure that any given failure was not a fake failure. But actually chasing down who broke the thing, if it's clear that there is a breakage, and usually it's pretty quick to verify that for the dev of the day, it doesn't end up taking too much time out of the day when it's a legitimate failure. Because we're testing often, I'd say the other thing, we're testing often and we're deploying often, so we're not building up a giant backlog of test failures and then trying to parse them out later, which I imagine would be a lot more time intensive as well.
Right. Well, in the interest of time, I'm just going to ask you kind of one last little advice question. Around this same topic, people are asking, you know, do you have any advice? They're saying where they are, developers only write the unit tests and they haven't been successful in convincing them to write UI and Selenium tests. Do you have any advice on kind of how to get them to do that?
That's actually a great question. That's a great question. I think in our case, we were probably lucky early on because we were all kind of investing in the tests. So maybe that's part of it is getting buy-in from the team during the development of the test framework, of the, you know, gathering the needs of the tests and that sort of thing. I think when it's something where it's, you know, there's a wall between the teams and you're saying, here's this tool, please use it. And with any internal tool that you're building, like when we're building our level builder for our educators, we try to develop it with them and getting their buy-in and getting their feedback, and I think that can make a big difference in terms of getting any sort of tool used and figuring out like what's really the pain point. I would ask the team too, why would they write tests? And I'd imagine it might come down to something like, you know, maybe it takes longer, maybe when they write a new test, the intermittent failures come up and they get bothered by them, so it's scary to write a test because you're kind of investing in the future passing of that test. But yeah, and it's kind of one of those things that I think it's kind of a snowball. Like as more people are writing tests, it's more likely that when you see a pull request without a UI test, you'll ask them for a UI test. And the more everyone feels the pain of long tests, of failing tests, then I think everyone has the incentive to write their things in such a way that are maintainable cross-browser tests and investing in speed ups. So I think I really feel like the speed of the tests, both in development and in running and in identifying failures, can make the difference in making that leap from having one person write all the tests to having everyone write tests. Because there's a lot of overhead, and if writing the test takes 3 hours, they're not going to do it. If writing the test takes 20 minutes, totally they'll do it. And if it'll notify them in their branch pull request before they even put their code in and break the tests, like that's great. That's such a better experience than afterwards finding out they broke something and getting yelled at about it. So, but it's a journey to get there. It's definitely not it's not getting those tests all set up in a pull request style and getting all the parallelization going and training up the team. It's probably not something you can do overnight, but yeah, I think it's a nice goalpost to have, and that's kind of where we're hoping to get to as well.
Right. Well, great. Well, at this point, we're going to have to go ahead and end the webinar, but we thank you for joining us. Definitely some great content there. If anybody has any questions, you can email me at webinar@saucelabs.com. I can also get you in touch with some questions for Brian if there was something that you really wanted to find out. But Brian, thank you so much for joining us, and thanks everyone for attending. All right.
Yeah, thanks so much. Hope everyone learned a little something.
Great. Thank you.
Thanks.